Yeah, quick intro. I did race solar cars. I will say I was not Max Verstappen actually driving them. I was on the support team and helping to design and build them. Also actually worked as inspector for the races for a number of years. Many other things about me there. Done one or two things. Okay. So one of the things that I found is a lot, and myself included, a lot of engineers, a lot of scientists, a lot of data scientists, you build scripts or tools to do your own work, to help you figure something out, to calculate something, and then that could be useful to other people. So you get thinking, well, what if I was to make this into a product? Something that I can sell and give to other people, and they can use it, and they can use all this work I've done over and over again. Now, I've done that with ChargeSim, and I'll tell you about that in a second. Oftentimes, these types of scripts can start off as Excel. It may sound silly, but often it works really well because everybody's got Excel on their computer. You can just hand it to someone. Most people know a little bit about it, and they can get it going. If you do Python, that works with some people, your colleagues, but handing out Python scripts to third parties, general public, gets very difficult. And so then you need to build a lot of infrastructure around that in order to turn it into a product that other people can use. For this presentation, I'm going to give kind of a helicopter view on this. We're going to jump into a few details of the implementation. There's an awful lot about this, but I'll touch on a couple points to think about if you're planning to do that. So quick introduction to ChargeSim. So ChargeSim is about 2 years old now, and it started off as an analysis script to help solve a problem, and we've turned it into a software as a service tool that we sell to clients, and then they're able to use it to go and do their own analysis. Now, we solve a very specific problem. It's not a problem that I suspect anyone in the room has, and if you do, come and talk to me. It's if you're buying, let's say, 100 electric buses. Anyone? No? Okay, I didn't think so. You want to figure out how many chargers you need, because these things will run 50, 100,000, 250,000 each. And so if you can figure out that for your 100 buses, maybe you're okay with 80 of them or 70 of them, that's a big deal. Also a big deal for your what you're asking your electric company for. Are you asking for 2 megawatts? Are you asking for 5 megawatts? That can be a $20,000 a month difference, 20,000 euro a month difference. So it gets interesting for the people solving that. So this is kind of what I do, and now next I'll talk about how we do it and some of the things. Quick disclaimer to get this over, get it out of the way. We do have some promotional credit from AWS, so I will talk about some Amazon stuff that happens to be what we're using. So I don't have a totally unbiased view on that, but I'll explain some of the trade-offs. And for most of these things, Google and Azure, and there's third-party tools that can do a lot of these functions as well. Yeah. So there are obviously advantages to have everything on the same platform. That if you have one login system and one billing system for everything, that's quite helpful. So the way to think about this to start is the script that you've perhaps built, your Python notebook, your set of scripts that helps you figure out whatever your problem is, data analytics, that sort of thing. That's the center here. That's this core of, in my case, it's a simulation engine. But in order to get users to be able to work with it, we need to be able to add a bunch of things. So for the simulations, we need to allow a user to set up a configuration and say, look, where do how many buses are we using? What type of batteries do they have? There's a lot of these questions. And the same thing, if you have your analysis script, you've got to be able to load in all the data and then get that into the same uniform format that your simulation engine or your analysis tool can work with. On the other end, so we've got a front-end part for that. In our case, it's React and then Lambda functions. And then on the other end, after the script is run, you collect all the data, you've come up with your brilliant, insightful answer, and now you need to share it and explain it with the users. And so they need some tools to explore that data, to plot it, to look at it quickly and easily. Next. Okay. Big lesson that I have discovered in doing this is there is a massive difference in the amount of effort between a script that you build for your own use, something that you can use, and if you get a bug, then you can just figure it out yourself and solve it, to something that you could give to somebody else to use and charge money for and as a product. And there is a massive additional amount of effort. And in this presentation, I'll talk about some of the pieces that go into that extra effort to, we need to put in. And I will also note, and as the CEO of a small company, there is also an enormous amount of work in sales and in marketing, and I'm excluding all of this. So this presentation, we're assuming you have your helpful business partner who can sell the stuff. If you're doing that as well, that's a lot of time. Next slide. So, give you a quick idea what the architecture we're working with is. So you have to frame some of it later. Front end, we use React because it's nice. There's a lot of people using it, so there's a strong base of libraries, and it's it's relatively easy to work with, and it gives a nice, fast, interactive experience for the users. Then we're using Amazon's API gateway, so that manages all of the different API endpoints that the front end is pulling the data from. I'll talk about that in a little bit more depth later. Then we have a whole set of Lambda functions, which will then do database queries, trigger the simulation engine, which runs in, it's a Docker container that Amazon starts up and runs, so Fargate. And so that gives you a quick idea of how we've built the tool. But then remember, going from our initial script is in this box in orange up at the top with the simulation, and then the rest of this, we've had to build all of this to make it accessible to users. Next slide. So users, unfortunately, add an awful lot of requirements to your system beyond just a Python script, for instance, that you can run on your own desktop. Because users have these weird expectations, like you kind of want to make sure that the right person is using it and that they have perhaps even paid you to be able to do this, that you don't want it open for everyone unless you're deliberately doing open source, for instance. Users are also they kind of like it when they can access only their data and only their data, and they would rather that somebody else doesn't see their data. So this means you need to add security, you need to add logins, you need to add authentication authorization. We'll talk about that in a bit more depth. The other huge problem that comes up is if you've built something yourself, you understand all of it deeply, and you can figure out if anything goes wrong, or you can understand all of those little trade-offs, and the way it thinks is obvious to you because it's the way you think. However, you start getting users involved, they don't understand all of that. And if the Vulcan mind meld, where you could just touch their face and imbue all of your knowledge into your user, you wouldn't have this problem. Unfortunately, that doesn't work. So we need to do documentation, and quite a bit of it, in order to make this accessible. And I'll talk about that in a bit as well. Next slide. So, turning our user needs into sort of more detailed requirements and into implementations, security comes in two parts. One is so some of the things I'll talk about here, there's authentication and authorization, and those are different, and I'll explain a little bit about that. We'll talk about documentation, and a couple things that I find really help with reliability. And again, because if something that you have built crashed, you can understand it, you can fix it, you can try again. If something crashes for your user, you need to deal with that. So next slide. So security is actually two different halves of a problem. One is authentication, and then the other one is authorization. Now, authentication is saying, are you really who you say you are? And this is making sure that I know that you are the right person. This is dealt with things like two-factor authentication, with usernames, with passwords. So now I know that you say you are Bob, and I'm really sure I've figured out that you really are Bob. The other part of this is authorization, and this is figuring out who is allowed to see what information. So congratulations, you are Bob. We figured this out, but are you allowed to see project number 75? It might be that Carol owns project number 75, but maybe she has said that she should share that with you, and so now we need to figure that out. So next slide. So yeah, authentication. Talked about this a little bit of what the problem is. My general advice for this is don't do it yourself. There's a lot of complexities that get thrown into this, like password recoveries, like sending SMS texts all over the place if you're doing two-factor authentication, a lot of details around encryption and you know, managing the identity properly. And this is also a super, super standard problem. Just about every web app has this type of problem. And so what that means is there's a bunch of tools out there that can provide authentication services for you. We happen to use Amazon Cognito, but there's Okta, Google, and Azure have their own identity and login systems. You can use single sign-in from, for instance, GitHub, like the PyData site does. There can also be GDPR implications. You know, if you know a lot of personal information about users, then you need to manage that properly. And all of these work mostly with what's called a JWT token. So I'll talk about that in a little bit more depth. And so this is a nice way to separate out the authentication from the rest of your tool. Next slide. So as I mentioned, there's actually a lot of complicated parts of authorization. Also think about how do you freeze an account, how do you change access rights. You know, you need interfaces and you need ways to do all of this in order to manage your users properly. Next slide. So other side of this is authorization. So now we're figuring out, congratulations, you're Bob. Are you allowed to see this project? Are you allowed to edit it? Are you allowed to view it? Are you allowed to do, you know, are you allowed to add, make it much more complicated? Does your license level allow you to do that, or do you need to pay more money first? Next slide. So to give an example that we will typically run into, there may be, our typical end user is, for instance, a transit agency, and they're planning out their electric bus infrastructure, and so there may be a project, and their staff may be involved with that. They may also have a consulting firm involved with that who can edit it. We may be supporting the project directly, and so then we may have view or edit permissions. And so there's all these different combinations. The consulting company may also be working for a completely different agency. And so we need to have an authorization system that lets us figure out who is allowed to see what. Next slide. We do this with groups, and in our case, we attach the groups to the JWT token, which I'll talk about in a little bit. But there's a variety of ways to do this. I don't know if any of you have worked with SAP systems, but they have an absolutely massive authorization, absolutely massive authorization system. Yeah, I see some nods there that they're fellow, other people who have explored this, because you've got all these permissions. If you're purchasing something, who's allowed to authorize, you know, who's allowed to approve spending, and who actually writes the check, and so forth. So let's talk about next slide. So now I'll quick introduction to JWT tokens. How many are already using JWT tokens, or already familiar with them? Okay, I see maybe a quarter of the hands going up, so that's good. I find a fairly effective solution to this, also because it allows you to put all of this the authentication problem you can hand off to one of these third-party providers fairly easily with it. So what we do is the user initiates a login, goes to, for instance, our service, in our case, Cognito. Cognito says, yes, okay, I've logged you in. Maybe I've done a one-time password. Maybe I've done just a password. Maybe have put in some security on your IP address, whatever is appropriate. And it generates a cryptographically signed and time and dated token that says, okay, whoever holds this token is now allowed to access the system for 1 hour or whatever you've set it up. The user is then able to take that, put that into the header of their API calls, which then go to the API gateway, and then in the Amazon case, the API gateway will actually validate that token itself. You can also put in custom validators that compare the cryptographic signature that comes on the user's token with the public key of the authority that's signing it, so the authentication or the authorization provider. And what that means is that you only ever trigger your own functions, your own Lambda functions that are, for instance, reading your database after you have fully approved that this is a valid logged in user. And so this simplifies it and separates the concerns quite a bit because, for instance, this part, the user will be, for instance, a standard React library. In our case, we use Amplify, but there's several of them out there to deal with the passwords and login. The JWT server is usually provided as a service. As I say, this is, could be Cognito, Okta, similar. The token validation, again, in Amazon, that's the API gateway system, takes care of that by itself. And then we only really get to it when we get to the back-end system doing the authorization and actually executing the function. And so those are kind of two steps that we need to implement, and the rest of it is largely taken care of by existing libraries. Yeah. Okay. So I thought I had more on that, but no, let's move to documentation. So help is enormously important to allow users to use a tool. So we have a user interface. It's got all sorts of different inputs. Typical one would be you need to put in what's the battery capacity of the bus that you're planning to buy. So we say, well, you've got to input that in, but there may be some details about that. There may be some complexities, or what's the unit. Capacity is a relatively easy one, but we have all sorts of other inputs which may be a little bit more complicated. And then the user needs to find out how that works. And so we have a little help bubble there. And we happen to use a tool called elev.io. And they provide sort of all the help file, or they manage all the help files and provide response to allow the user to rate them, say this one isn't very good, keep track of revisions, that kind of thing. So there's a variety of different solutions for that, but it's definitely one to consider in building your system. Also keep in mind you need things like training programs, you may need user manuals depending on the complexity of your product. You'd like to think everything can be beautiful and super obvious and easy to learn, and if you're building it, it usually is to you because you've been building it, but for other people they need all of that support. And a big rule that I have found helps with this is the ticket isn't closed until the documentation is done. So don't allow yourself to move on onto other projects until it is really usable by a user, including all of the information needed for it. And also starting the documentation can be a way to help refine and think through the requirements for the function you're implementing. Next. Okay. Now, talk about getting the system to be robust and reliable. So this is also one of the things that I found going from something that I use myself. If I hit a bug, I can just deal with it. If I give it to a user, it needs to be really stable. So there's a couple things we can do to improve that. It's also obviously essential for the clients to trust the outcome that they're getting. So a few things we can do. We can have feedback mechanisms, and I'll talk about some of those. We can do testing, so unit and overall testing. I won't talk too much about, or I won't talk about that. Reducing the chance of errors, and that's where I find schemas and static typing are really useful. On the one hand, working in Python, we're like, no, we all love dynamic typing, but as you get towards production, I find that actually becomes more of a liability, and so putting in more static typing helps. Next slide. So users tend to find their own way to use the tool, and I always get surprised by this. I give it to a user, and then they've figured out some other way that they can enter something in, and it could be really simple. It could be, we want to put in the power of the charger. Well, is it 22 or 22 kilowatts or 22,000? I mean, all of these could be valid, but if you don't check it, if you don't enforce it, if you don't make sure that, for instance, it's a number and not a string, these can turn into bugs. And this is where things like static typing and schemas are really important. So the sooner you constrain all of these, the less problems you have. Next slide. So schemas and static typing, again, kind of annoying coming from Python. My experience is generally, Python is great for getting things going really fast. But then without the static typing, it becomes a liability longer term, and it becomes more difficult to maintain. If I look at something like JavaScript, which is the basis for React, it's then weakly statically typed. So it's very flexible about saying, oh, well, that you put 1, 2, 3 as a string, but I think maybe that was supposed to be a number, or maybe that was supposed to be false, and kind of massaging it a little bit. It also uses undefined quite a bit, and I find that actually it works okay on a front end because it tends to try and push through bugs if it hits them. Occasionally you get not a numbers, that type of thing, but in the back end that can just turn into a liability. And then JavaScript is strongly typed, or sorry, Java would be strongly typed, and having worked with that, that actually has an advantage that you hit a lot of problems at compile time that in other languages you wouldn't see until you are actually executing the code. So type hinting in Python, and that's becoming increasingly popular, I think in the later, like 3.9, they're implementing more of that. But even in earlier versions, it's really helpful because your IDE will probably coach you on a lot of this, and it actually helps a lot just with the documentation and code completion and speeding things up. JavaScript, of course, has TypeScript, which is the typed version of it. Starting to implement some of that. Again, it can be really annoying, but it's finding bugs before you hand it to users to find bugs. Next slide. Schema is an API. So the API gateway that we use, we're defining all of it in a tool called Swagger. And this is now OpenAPI. So it is a very long YAML, I believe, file that defines exactly what the interface is going to be. And if that schema is not met, it won't even trigger it. So next slide. So for instance, if a user tries to send in a message where it's got a string instead of an integer, for instance, it's just not even going to get through. So they can't ask for project number, semicolon, drop table users. And so this is quite helpful. This can get very long, but it also generates documentation for your system, because you can now see when you go back 6 months later, what was that supposed to be an integer? Was that, what were the valid enum values in there, that kind of thing. So you can put all of that in, and so I'd highly recommend using something like a schema to validate your inputs and to help generate your API. Next slide. Errors. So this is a big one. Do we know how we cause what this is from or how it's caused? I mean, I might have a guess at it because I made it. However, if I'm a user, I have no idea, and I have no idea how to fix it. So I've got to deal with errors. Next slide. So what we need to do this is we need some kind of a logging library. We need a way to collect all of these problems and handle them. And I'm running out of time, so I'm going to go next slide. So I think of errors in 3 categories. One is a user error. This is nothing wrong with the code. This is something that the user has done that is wrong, and you just need to explain it to the user and coach them to do it better. This could be something like saying, I want to try and simulate 35 buses when I only have 30 parking spots. It's just not going to work. And so you just need to tell the user, yeah, I just can't do that. You've got to change one of these numbers to make this work. Second type is a software assertion. And I put these all over in the code. In this case, we're doing a physical simulation. So we know that, for instance, conservation of energy should probably be respected. And if something in the code says that that's not true, then almost certainly the code is wrong. So we can check that, and we are much better off to hit that, stop the system, and just say, we have a bug, we're going to solve it, than we are to present a wrong answer to a user. The last one is then the software error, where it's going to outright crash, and it's something that hopefully the compiler or you've earlier picked out, but they happen occasionally, and it's just the system doesn't work. Next slide. The thing that I have found really helpful for this is just encapsulating everything and then using, in our case, we use a tool called Sentry, and it adds a library that you can add into the headers to basically all of your files and all of your languages. And then anytime an error happens anywhere with users, with your own system, with the back end, it gets fed into the Sentry system, and you get a report of it. And this is excellent because I've even had cases where I get a Sentry report that a user has hit some kind of bug, and I'm able to very quickly find that, fix the error, and frankly keep the user happy by saying, yep, we understand what went wrong. We don't need to spend a lot of time. Can you replicate that? Also, users often won't report all of the bugs that they see or all of the errors. They'll work through it. They'll find workarounds. It's not their job to make your tool better. So getting a good overview of where problems might be is really helpful. Next. User errors, you need to tell the user, as I mentioned. And we need to do this in a clear way. I find it helps a great deal to have a error code name that's reasonably verbose, so it's actually a readable name that explains what the type of error is. Next, and I'll talk about how to write error messages, and I think of 3 things that should be in there. One is we have an error code so that we can link it to our help files, to our documentation. 2 is we want to know what the error is. Okay, there wasn't enough parking. Now we need to explain to the user why it happened. Okay, you were simulating 80 buses with 30 parking spots and it just won't work. So you have to explain that to them. And then the third part is how to fix it. Okay, you can go back and you can adjust the number of parking spaces, you can adjust the number of buses. And so when I write documentation for error files, I make sure to include all of these 3 elements, and I even have it in a template that they all fit on exactly the same approach, because we want this to be usable to the users need to be able to understand this. Next slide. So, conclusion. Moving to a product is a huge amount of effort, and it requires thinking about user interface, user accounts robustness, and there is a huge gap between the script that you've built for yourself and something that you can hand to someone outside and that they can go ahead and use it. But these are some of the tricks and some of the tools that I've found to help accelerate that. Next slide. So other shameless plug here, we are growing, we are looking for developers, and so we are working on a very geeky way to help save the world and reduce greenhouse gases by transitioning more vehicles to electric at lower cost. We're also a very small company, so unfortunately we're looking for people who can be really effective without a large number of project managers, scrum masters, middle managers, carefully focused on their organization or their OKR of getting a larger car, specifically the A6. Yeah, so check out chargesim.com or come talk to me later if you're interested. Next. Any questions?
Any questions for Andrew? Okay.
Yeah.
Yeah, I was wondering if you're also treating your developers as users. So
Yeah, it's a very small company at the moment, so there isn't too many choices there. But that's actually one of the key things I find in. Like, I do a lot of the software development, and I also do consulting work with clients, helping with this. And I find the consulting work is really essential to get that feedback, because I understand what the problems are, and I'm working closely with the other consulting companies that are involved to understand the problems. So yeah, getting that short feedback loop, I think is I mean, frankly, that's the huge advantage that small companies have compared to big companies. All of those layers of management that I joked about, I mean, that is as you get to a bigger company, that ends up being an unfortunate necessity, and it slows things down. Yeah.
yeah, and one thing, for example, we are doing is you make the Python package available to users in your company. I guess for you it's not such a big problem, but if you have a big company, you would just want to pip install the simulator.
Yeah, yeah. So there, I think I had it in the effort slide that there's also the effort required for colleagues. So you know, for instance, if you're just handing out the script, it's got to be documented. The errors have to be clear. The user authentication may not be a problem, because it's just like, yeah, if you have access to the company server, then that's taken care of. So there's different parts of that. Yeah.
Question about documentation. How do you help focus on documenting the right thing? Because I feel like often you end up documenting everything that's easy to document, but the actual tricky things end up not, and you have too long didn't read the documentation, but when I searched for something, it wasn't in there.
Yeah, you're absolutely right. It is super easy to write a document that explains what a kilowatt is. It is way more complicated to explain how this interacts with everything else and why it's really important. Yeah, I don't have it's a good question. I don't have a brilliant answer on it. I think part of that is also on kind of user feedback and training users, what are the parts that they don't understand, and then helping to, using that as a feedback path to improve the documentation.
Any other question? Oh, yeah.
Yeah, I was wondering if you also fuzzy test your code to find potential bugs and errors.
Yeah, so we have quite a bit of unit testing built in, and then we have sort of standard test cases that we run. So there's quite a few things that we've put in for that. I didn't touch upon it in much depth here, simply because I've got half an hour to discuss a huge subject. Apparently,
It's okay. No,
apparently that's the end of the half hour. But yeah,
no, we can take one more short question if there is any other. Or no, okay. Yeah. Oh, Philips.
Also about documentation, so you suggested to start with documentation, right? Which I also see the point. But on the other hand, if you're working on exploration activity, then you really have to do several iterations to be able to reach to what you are looking for. So how do you see that?
I think of that, there are, it's a good question. So there are activities that I see as more of a research activity versus more of a development activity. So the research activities, I don't worry about it so much because I know as you say, I'm exploring, I'm trying to figure out if there's really something useful there. And so there I'm kind of doing it more, for internal iteration, as opposed to once you say, okay, this is a feature I want to launch to customers, then I know the documentation has to be an important part of it. So I just put it in that kind of separate out the research activity from the development activity.
Yeah, because the research activity also it ends up development at the end, right? So.
Well, that's, yeah, so if I think about it there, I would call it a research activity that I'm exploring, is this worth doing? And I have maybe a 50% expected chance of success. If I now say, all right, this is something I'm going to give to users, then it turns into more of the development activity. And in the case of this tool, there's often quite a bit of work that happens in kind of the simulation engine. What new features can we simulate that we can do as the research activity, but then when it gets to adding all the buttons, and then it's going to be user facing, and then we really have to go to kind of the development mode and say it's got to be documented, it's got to have X number of tests and all of the good things you do to make sure it's ready for production.
Yeah. Okay. Thanks.
Awesome. Then.